And so how hot does it get on a rooftop? We saw 60-degree temperature adder can actually go into PV watts and look at your rooftop temperature in your area. So you go to PV watts, download the hourly data, and you can explore the coldest temperatures and the hottest temperatures. Maybe not on record, but in your normal operating environment. You can assume the cold temperature side of things is going to be a little bit harsher. And generally, when you're looking at your temperature conditions, you're using the record low, but they let you get away with the ambient high because that hotter temperature, to some extent, is going to start dragging back your system performance. So, anyway, how are these fires starting? Well, code has gone a little disconnect crazy. This is over in Australia. This is not a US code thing. Australian code and US code have a lot of similarities. Believe me, there was a time when US code was looking at doing what they do over in Australia, which is putting a disconnect switch right alongside the array up on the top of the roof. It's like, okay, well, there's roof-mounted air conditioning units and commercial settings have disconnect switches. The problem with a disconnect switch on a rooftop is not the switch itself, it's the roof. It's a very hot environment. And by cutting that wire inside that disconnect, you're inserting a failure point into the system. And the terminals on those boxes where the cable hits the box is one of the hottest points on the system. Now, wherever you get a failure, wherever you get a splice or an inefficiency, and electrons are having to leap over that, that's not a good, strong point within any electrical system. Down at the cell level, you get impurities on these solar cells. Electricity starts hopping across, and the cells can start to degrade along the line of the little micro crack that the electrons are jumping over. So a terminal point where the cables come in and landed on a metal bar gets hotter than the rest of the box. And so the problem becomes when you build a solar array, then you're like, oh, I need to have a box up on the rooftop. So you go to Home Depot and you buy a box and a terminal bar, and you're not using solar specialty parts, but you're just using stuff that they have at the supply house. And this more generalized balance of system material stuff might only have a 60-degree temperature rating or a 75 C temperature rating, whereas everything else, your solar cable, your solar panels, the inverter, everything else in the system is designed with a 90 C temperature rating. And so if you've been doing all of your temperature calculations, assuming a higher temperature rated device, and you go and swap it out with a lower temperature rated device, then we saw with those temperature correction factors that the temperature derating for lower temperature devices, oh, come on. We saw that when you use a lower temperature device, that the derate factor is substantially larger, 70% instead of 40%. And so the rooftop isolator boxes in particular, especially when you're not using specialty solar high rated temperature devices, you're just going to the store and buying something off the shelf, you might have a temperature mismatch, at which point those terminals become the hottest part in the system and can smolder and catch on fire. Another aspect is debris can accumulate underneath the solar array, And if you get debris accumulating around that box, that can be a fire hazard as well. To the point where it's not a bad idea to budget a little more money and put a metal netting around the perimeter of the array. Most installers don't do that. I'd say it's not a standard practice, although I know solar companies who have it be a standard practice. What I would say is if there's trees nearby, to the point where it's not just that there's branches nearby, but that you could get leaves falling onto the roof under certain conditions. If you get leaves on the roof, you want to have a net around your array so that those leaves do not get underneath the array where they can get caught up on the racking and the wiring. All right, so now we have some more rules for metal clad cable. Secured at intervals every 6 feet. 10 feet for vertical drops within 12 inches of a box. We say, so. I guess you don't need to attach it to every single rafter as you're going across the rooftop. And here's another kind of cable, power cable, TC cable. This stands for tray cable. And what we'll talk about in a minute is something called cable tray and how useful it is, particularly on commercial job sites. Tray cable probably can go inside a cable tray. It's probably cable that's designed to go inside of cable tray. And it says assembly of 2 or more conductors. So that's why we're calling it cable rather than a conductor. It's a cable with 2 or more conductors, with or without a ground. And it has a non-metal jacket. So NC cable is metal clad cable. TC cable is general plastic without the metal cable. You might put it in a metal enclosure. It says TC ER cable is permitted as interior wiring. It's a non-metallic sheathed cable. It's also robust so that it can be direct buried. It gets that outdoor rating as well. So TC cable is a common cable, and it's commonly used for like AC microinverter circuits too, where you won't have to put it in metal at all. So normally if I'm doing microinverters, running TC cable, from the service panel, up to the metal box that's kind of built into the roof, the transition box is fine. Service entrance conductors are also useful in the solar industry. Service entrance could be underground service entrance, and a lot of utilities will not have underground conduit from the side of the road where the power transformer is to your house. Maybe only 10 feet of that will be conduit, and then they'll transition into the earth just to make the pulling and the installation of that underground cable easier. So USE cable is useful for ground mounts, direct burial. Some other kind of wrapping up our cable discussion, some other types of cable. There's intermediate metal conduit, which is a little bit stronger than EMT conduit. Then there's rigid conduit. Rigid is pretty common to be waterproof and watertight, whereas EMT, metal stuff, that's used indoors pretty frequently where you're already in a dry environment. And so you can in the solar industry, we're not trying to have a lot of money spent on our conduit, a lot of protection on our conduit, and we're usually going in with EMT conduit. But you have to check the weather ratings, to make sure that your fittings are rain tight rather than just indoor. Whereas rigid, those fittings for rigid are usually always watertight, also much more expensive. There's flexible metal conduit. It looks like metal clad cable. We were talking about it earlier. Then we have this liquid tight flexible metal conduit. And that's pretty useful because it's metal, and so DC wiring, solar cable has to be in metal when inside a building. B, it's flexible, and so sometimes the end runs of your conduit having that flexibility is useful, or being able to run it through an attic can be useful. And it's liquid tight, so it's waterproof. So this is a conduit that can kind of do everything. Running liquid tight flexible metal conduit from the roof down to the battery room would be a code compliant job where you don't have to worry about anything. In battery rooms with lead acid batteries, you have to paint or insulate the cable to prevent corrosive deterioration, and this plastic on the outside of it is worthwhile. Now, where this liquid tight flexible metal conduit gets confusing is that there's also a flex conduit that doesn't have any metal in it, and that's just called flex conduit. So the liquid tight flex metal flex is how you would refer to this ordering it at a supply house. We got PVC. This is not white plumber's PVC. It's gray. It has a little bit better deterioration ratings. So let's see. Flexible metal tubing is not permitted in battery rooms. That's that metal tubing with the holes in it, because battery rooms can have corrosive gas. They want a more solid enclosure. So we can use liquid tight flexible metal conduit instead. Costs more. And finally, so now we're getting to something that isn't conduit, called gutters. And a lot of kind of self-educated electricians, solar installers, this is where they start to not have as much experience. The gutters still have that 40% fill, 25%. 25% conductor fill and 40% or 40% conductor fill and 75% cross-sectional area fill. I think this is staying away from the edge. What do these look like? All right, some pictures. So we're making our way through the wiring and cabling section of code, and we've defined conductors, we've confined cables, we've defined conduit that would surround conductors, and now we're getting to even more rare kind of enclosure called gutters. I'd say rare. You can walk around and see them, but they're these long rectangular prisms that it's common just to see EMT little stubs of conduit going down into. So here we have little conduit stubs going down into this gutter. couple of conduit stubs going out into this gutter. And what does that gain you? Why do we use these gutters? Well, because otherwise you would have to take this run, and let's just assume this is from a solar array and it's landing on this inverter, or maybe it's probably going back to the electric service panels. The solar stuff, I'd say, is going to come in through here. But if you didn't have these gutters, you would be running conduit down and looping it around on the wall in these big loops. And then you might have multiple conduit runs. So over here on the left, we have 4 EMT runs up to this section of the rooftop, and we have 4 EMT sections running off onto that section of the rooftop. And each one of these sections has to be bent and made up and attached and drilled and knocked out, and then the fish cable put through for your conduit pull, and then that taped off and tied to all the conductors that have to be prepped individually when you're pulling them, so you can pull them through all at once. And on this particular project, the plan set called for EMT conduit, and it turns out this is material-wise, it's cheaper than that, which is cable tray. You really only see cable tray on commercial systems because of its cost. It's, even by the foot, you're getting into, I'd say $12 or more. And so that can get quite pricey for the conduit run. But what does it gain you? Why do we use it in commercial jobs? And even here in this, I'd say high-end looking residential project, this is not my project, it's Ben McFeeder's on Facebook. But he's using, gutters as kind of like a residential poor man's cable tray. And this, it depends on, that DC wiring needing to be in metal. This is probably the DC side. If you wanted to be completely code compliant, maybe inside here you maintain some metal, or you make this particular box metal and have this be AC and have it be plastic, or these might be metal gutters. I can't really tell if they're plastic or metal from here. Well, if you use gutters or cable trays, then you're just making this run relatively simple. There's parts in cable trays for flexibility, and then you can just kind of walk through and lay in and line the cable into it. So the actual cable run itself is substantially is faster. Now, on top of that, getting all of this straight, making all the bends perfect, and all the kickoffs and setbacks is difficult. When we initially installed this, what the array ends up here. So we said, okay, we got a 90-degree bend, and then another 90-degree bend, and a third 90-degree bend, and then our fourth 90-degree bend to land on here. So we could have use 2 sticks of conduit and have a nice smooth bend. I personally don't like using unnecessary LBs. This is, instead of, we're not making 4 turns before we land on this LB, and we're not making 4 additional turns before we land on that LB. What happened is the client came back out and said, well, we see your conduits looping off the side of the building and looping back down, and we're like, well, yeah, that's what's on the plans. And he said, well, okay, well, we didn't define it. We want our vision was that this conduit hugs tight the building. So, we redid it to make it look better, and admittedly, it does look better, but also admittedly, cable tray should have been specified instead. because by the time you end up, you evaluate all of that work, you're spending as much on labor instead of getting a higher quality finish. So what the gutters do is it allows you to simplify all of this stuff. We have 8 different circuits or 8 different conduits that might contain 2 or 3 circuits in them landing inside here. And each of these circuits needs to get divided between multiple inverters, and then also come out and go into a broader box before we get back, to our main point of interconnection. And so what the gutters do is allows you to grossly simplify all your cabling coming in and out of the various conduit runs. And it also gives you these nice and straight little short stubs between one section to the next so that you don't have to deal with all the complicated bends and parts and fittings. But this sort of stuff is best pre-designed. See, we have I just wanted to include this slide because it's a mention of electric vehicle cable, which is a high voltage cable of conductors of various sizes. That's kind of interesting. It's a little bit more of a flexible cable. I'm used to using kind of welder's cable for inside of large battery banks for ease of wiring. Might have to look at the EV cable instead. There's a solar cable too. It's called PV cable. It's high voltage, super thick jacket, exposure for sunlight, high temperature, wet environment. All right, so now we're making it into section 400, which is general equipment. So this again has a lot of repetition because it will cover, batteries, for example, even though batteries have their own section later on. So, maybe when equipment in the general equipment gets to be so special that they warrant their own section of code, code gets expanded and shoved off towards the end. But we got switches, like a big old knife switch disconnect on the side of the building. Can you use switches as a raceway? It says enclosures should not be used as a junction box or a gutter or a raceway for conductors feeding through or tapping off to other switches unless the enclosure complies with a certain section. We already covered this section. That's the section where it's talking about the 40% full with conductors or 75% full with other stuff. So you are allowed to, put a tap connection inside a box, inside a meter can, inside a device, but not if it fills up more than 75% of the surface area. So damp or wet locations. So we have to make sure that if it's in an outdoor environment, if it's wet, if it's underneath an awning, that we're using wet rated boxes. Since we have this picture and we're not too far away from it, it's a little hard to see, but there's these little black connectors on that EMT, and you can kind of see these little black connectors here. And then on this picture, this indoor picture, you don't see, they're just metal connectors. You don't see any coloration. That's the difference between an outdoor rated connector and an indoor rated connector. The outdoor rated connectors have a little bit more stuff on them. Actually, yeah, so basically these rain tight EMT connectors have more robust caps and inserts on them to prevent rain from getting into there. And the thing about it is these rain tight EMT connectors, you have to buy them at your supply house, and they're rare because it's really only solar installers who use them, as far as I can tell. Most other outdoor electrical products are either going really low end and are AC and are not, shrouded in metal like an air conditioning circuit, or they're high-end commercial industrial projects and they're using rigid instead of EMT, and rigid's already rain tight. And so the availability of these rain tight EMT connectors, you can't find them at your box stores, and often they're a special order item at your supply house. So that I think is a common kind of error. And maybe if you're putting outside of conduit cable inside of that EMT, you might argue to your inspector that we're just doing this conduit for physical protection, but we're not required to be in conduit, so the environmental rating of the conduit doesn't matter. I don't know of I'd say inspectors would go 50-50 on that argument. If you're using inside a rated conduit, like THWN2, it's a wet rated conduit, but it's a cable, but it's not rated to go outside a conduit. You would still need to respect the environmental ratings of the conduit. I mean, just because you're using rain tight fittings on EMT conduit, it doesn't mean the inside of that conduit is in a dry environment. So here's an interesting one. It says for switchboards and panel boards and switchgear, the directory should not be handwritten. And so, we'll see in labeling requirements, locating disconnects, putting inverter voltages and amperages. Back in the day, we would just have stickers that were blank, and we just use a Sharpie and write the voltages and amperages on the label. It's more professional, if not required. There's certainly parts of code that say, hey, this placard or label cannot be handwritten. And so if you're field labeling something in the field today and writing in numbers with your hand, it's tomorrow's code. They might say, oh, we haven't updated that section, but they could easily roll out none of this stuff is handwritten anymore. It's not too hard to get custom printed stickers made, and so we want you to do that instead. So unused openings shall be closed. So what that means is if you drill into a box for your conduit run and then you end up not using that hole, there are plugs you can buy to fill that hole. You don't just leave a hole inside your electrical box, because you'll get wasps and critters nesting inside, which is a nuisance by itself, but could cause issues too. Panel boards, switchboards, and switchgear should be 3 feet from the ceiling. Overcurrent protection of panel boards. So what does that mean? Well, we have a service panel, and it has its breaker slots on it, and then we have our main breaker. That's our overcurrent protection for our panel board. It says the panel board shall be protected by overcurrent protection having a rating that's no greater than that of the panel board. Okay, well that makes sense. If it's a 200 amp service panel, we can't, as its main breaker, have that be 240 amps. Otherwise, it's not, going to be compliant. Sometimes you'll get a 225 amp main breaker on a 200 amp panel, but if you go and look at the inside of it, they've actually given that bus bar rating a 225 amp rating. It's an unusual circumstance. And so they say, okay, there might be some different circumstances. We'll talk about that in the interconnection discussion in a little bit. Just in the interest of time, I'm going to kind of move the discussion along so we can get into batteries and solar. This is saying for backfed devices, there's a additional requirement where the backfed device needs to have not just be snap-on, but be a screwed in. But then they give you exceptions that cover solar panels. So we'll get to those exceptions later. Panel boards need to be connected to grounding. We'll see this come up again. So grounded conductor terminals. Let's just keep going. So we have sections for motor controls and motor circuits whose overcurrent protection sizings might be a little bit different than normal. So with a motor, you have a throttled, controlled output, and you don't want the motor to be running too hard and overheat and load up. So I believe with the motor overcurrent protection, it's not a 25% oversize, it's a 15% oversize.